Good morning, students. Today we're going to begin a new topic that we're going to be doing for the next couple of weeks. They're called sequences. Sequences are functions. And basically a sequence is a list of numbers. Here's an example: 2, 6, 10, 14, 18. And then you see this dot, dot, dot. Just means that the numbers just continue going on forever, right? Infinite. Each number on the list is called an element of the sequence or a member of the sequence. So 2 is an element, 6 is an element, or 2 is a member, 6 is a member, 10 is a member of this sequence. Each element has a position in the sequence, and we use A to note it. So let's take a look at that sequence again. I wrote it right here: 2, 6, 10, 14, so on. And the first position is A1. Notice that I put the subscript instead of on top, right? That would be the power or exponent. We put it on the bottom because this means position. So A1, the first position. A2 is the second position, which is 6. A sub 3 is the third position, which is 10. You can also write it as A of 4 or A of 5 for the fourth and fifth position. So I want you to note that there are no zero or negative number terms for the sequence, right? So you don't have position 0 or you don't have position -1 or anything like that. It's just a natural list of numbers starting with the first one and you continue going on. So let's just do a quick practice. Here's a different sequence. We see this sequence, and of course you see the dot, 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 which means it continues on beyond what I listed here. What would be A1? So A1 is the first position. So A1 is equal to -3. I can see very clearly that -3 is in the first position. What is A sub 2, right? Or A2? It would be 0. A3? 3. And then differently, we can also say A of 4. What would be A of 4? Well, 1, 2, 3, 4. That would be 6. A of 5. 1, 2, 3, 4, 5. That would be 9, right? And then we have 6. What about if I asked for A of 7 or A of 8? Those are beyond the fifth position, and we'll get back to that in a little bit. So one thing to note about sequences is sequences are patterns. There is a pattern to every sequence. So let's look at the sequence that we just worked on before. If you look carefully, to get from one number to the next, there was some type of operation that was happening. So to get from -3 to 0, the operation was that if you added 3, you could get there, right? From 0 to 3, what do you have to do? You also have to add 3. To get from 3 to 6, I add 3, 3 to 9, and so forth, right? So all sequences have some type of pattern. We're going to call this pattern a common difference. So there is a difference between every number, and it's the same difference. It's a difference of 3. Okay? So we say common difference. We also denote it as the D. So let's go back up here. If I were looking for A of 7, and I only have the first 6 numbers, I can actually find the difference, which we saw was +3. And I can actually see what the next numbers would be based on the pattern. So I know that A of 6 is going to be 12. So A of 7 must be 12 plus 3. What's that? That would be 15. A of 8 would be then 15 plus 3, which would be 18. And you could keep going and find as many positions. So final thing, just want to look at one more pattern, one more sequence. And here we have 9, 14, 19, 24. Take a look and tell me what the common difference is. if you checked, you should have seen that the common difference was 5. Right? So the common difference is 5. What would be A1? That's 9. What would be A2? 14. What would be A5? That's beyond the list, but I know that I have to just add 5. That would be 29, right? Oh, as usual, I don't give myself enough space. And A of 6, let me move it up here. A of 6 would be 29 plus 5, which is 34. So please go back, take a look at this, pause, take notes, and use this information to help you complete tasks 2 and 3 for the assignment. Bye.